Okay, everybody. Today we're going to talk about solving exponential or logarithmic equations. We've already done a bit of solving exponential equations, right? You make the basis the same, the exponent's got to be the same. But what if we can't do that? What if we can't make the basis the same? So here's the steps. You might want to write this down, print it, or something. Okay, if you have an exponential equation, you're going to take the logarithm of both sides. Remember, a logarithm is an exponent. Just like I can square both sides of an equation, or I can square root both sides. Now, as long as we're doing both sides, not individual terms, I can also take the log of both sides. If I start out with a logarithm in my equation, change it to exponential form. Because they're inverses of each other, we're going to do the opposite. If it starts out being an exponent that I cannot solve, take the log of both sides. If it's got a log in the equation, change it to exponential form. Okay, notice if you have log with base A of some function and log with base A of a different function, really I get a shortcut there. I could just drop the logarithm. Okay, that'd be the same thing as up here as if we took the log of both sides. So I could just drop it. These two would be equal. Okay, some more complicated ones, we'll look at that. And then, most importantly, check that each proposed solution is in the domain. We have finally found our third time. There are 3 times that you have to check your answer. You cannot have a 0 in a denominator. So if you have a rational function, you have to check your answer. You cannot take the square root of negative numbers and stay in the real numbers. So if you have a radical, you have to check your answer. And you cannot have a negative argument in a logarithm. A logarithm's an exponent like a radical, so it's the same thing. It can't be negative inside there. So we have to check our answer on those logarithms. Okay. So give the solution to the nearest 1,000th. Here's what I was talking about before. If this problem would have been in our previous section, 7x, 7 to the x equals 49, all I do is change that 49 so that it has the same base, and I know x equals 2. Okay, so that's by far easier. So don't forget to check that. If you have an exponential equation, first see if you can just make the bases the same. But here I can't. There's no common base between 7 and 12. Okay, if you can't make the bases the same, take the log of both sides. And we want to do either log, I can take the log of any base, but of course, once again, either natural log or log with base 10 so that we can plug it in our calculator and get an actual answer. And again, just because it's shorter to write, I'm going to take the natural log of base of both sides. Natural log of base 10, I started to say. Natural log of both sides. Okay, now that allows me, because of my properties of logarithms, to bring that variable out to the front, and then I can solve for x. Remember, this natural log of 7, that's some number. I just don't know what it is. You know, it's like having 1/2 raised to the 4/3. It's a number. I don't know what it is. I can figure it out. I can plug it in my calculator. But the x is what we're solving for. So let's divide both sides by natural log of 7. Okay, and x equals natural log of 12 over natural log of 7, and that we can put in the calculator. Now caution, this is what we were talking about last time. Get my calculator. You can't cancel those natural logs. That's not 12/7, right? It's the natural log of 12. It is not the number 12. So natural log of 12 divided by natural log of 7 is 1 point, let's see, round to the nearest thousandth. So 1.277. 277, and that is rounded to the nearest thousandth. Okay, because it's an equation, remember you can check your answer also. If you put it in this rounded version, you're not quite going to get 12, right? leave several decimals, but you know, we'll get very, very close to 12. Okay, here's a caution. It's what we were just talking about. Don't cancel those natural logs or logs, right? These are not the same thing. So just be careful about that. Remember, if we have natural log of 12/7, we write that natural log of 12 minus natural log of 7. And you can plug those two things in your calculator, actually, if you're not convinced, and see that, oh, you get the same thing. This is not the same thing. Okay, so we're still just solving exponential equations, and I cannot make 3 and 0.4 have the same base. That's the first thing to look at. That's by far easier. So I'm just going to take the log of both sides. Because now I have a property that lets me bring that exponent down. And don't forget, right, that whole exponent needs to be multiplied. Okay, so now at least I have a linear equation instead of an exponential. I've got to solve it. So let's get rid of parentheses first. Distributing. Remember, these natural logarithms are numerals. I just don't know exactly what they are. So they work just like a numeral. So 2x times natural log of 3. -1 times natural log of 3. X times natural log of 0.4. Okay, so now that I don't have parentheses, I need to think about what's happening. I'm trying to, this looks like a X there instead of a plus. Let's fix that. I'm trying to solve for X, right? X is the only thing in here that's a variable. Everything else is a numeral. Okay, so I need all my X's on one side, so I'm going to move this over here with this X, and I need my constants on the other side. So I'm going to add natural log of 3 to both sides. So now that's gone, right? And I'm going to subtract this from both sides. So that's gone, big fat 0. Okay, so now I have 2x natural log of 3 minus x times natural log of 0.4 equals 2 natural log of 0.4 plus, oh, sometimes it's not even funny, plus natural log of 3, right? Okay, now these both have an x, so I can factor an x out. Right, just factor an x out, just like a regular algebra on any other kind of problem. Don't let it mess with your head that we have these LNs or word logs or anything in there. Just treat them like a numeral. All right, now that I've got my x multiplied by something, then I can divide by that exact same thing, as long as I do the same thing to both sides. And then it'll cancel over here and just leave x equals this stuff. And this is all numerals. All I got to do is plug it in my calculator. Okay, now on the test, we're just going to leave it like this, right? Because we're not going to use a calculator. But on your homework, it's going to want you to give a solution and round to the nearest thousandth. Remember, I need these parentheses around my numerator and denominator. Don't forget, when it opens a parenthesis here, you got to close each one of those also. So let's see if you plug that in your calculator, if you get, let's see, 2 natural log of 0.4 plus natural log of 3. Don't forget to close both of those parentheses. Close the 3 parenthesis and that parenthesis. Divided by, open a new parenthesis, 2 natural log of 3. And be sure you close the parentheses. Minus natural log of 0.4. Okay, look at it in my calculator. Make sure it looks okay. Got all my parentheses accounted for. And it says round to the nearest thousandth. So we should have negative 0.236. Get 5, 7, dot, 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 dot. So that'll round to negative 0.236. Okay, let's try it again. Because what I have to be careful of before, just like when we're doing a radical equation, because a radical is an exponent, a logarithm is an exponent, so I have to have this part isolated. I have to have this part isolated before I take the log of both sides. Remember, if I were to take the log of both sides right now, I don't have any property that helps me with my argument having a plus in it. We only have product rules, quotient rules, power rules, right? Okay, so first of all, I'm going to subtract 1 from both sides so that that's gone. So 3, I'm just going to, doesn't matter, right? Just be careful and use appropriate notation, equals 99. Okay, now I'm going to divide by 3. This is my exponent. This is the thing I want all by itself, right? So 2 to the x minus 2 equals 33. Now, just take the log of both sides, or in my case, the natural log. Okay, now I have a property of logarithms that lets me bring that exponent down. Okay, just like before, let's distribute. Get rid of those parentheses. Let's add 2, because this is a numeral. The only variable term has an x in it, right? So let's add 2 natural log of 2's to both sides so that that becomes 0. Now to get my x by itself, since it's being multiplied by natural log of 2, if I divide both sides by natural log of 2, I can divide that out. So x is natural log of 33 plus 2 natural log of 2 all over natural log of 2. On the test, we would stop right there. If your homework asked you to give a numerical answer, I'd plug it in my calculator. So natural log of 33 plus 2 natural log of 2 divided by natural log of 2. And I get 5.104. Well, let me check that because I see it when I double checked what it looked like. I don't think missing that parenthesis right there will make a difference, but I better double check. Oh, it did. Okay. Woo! So I'm glad I caught that. It's always nice to look back at your calculator and make sure that you have gotten all parentheses in there accounted for, because that changed this answer to, I didn't close that parenthesis is what happened. And I thought, well, that's not gonna, oh yeah, it would, because then it's gonna put that all inside, right? Okay. Okay, so 7.044. Better, better, better. Okay, careful with those parentheses. All right. Okay. Solve each equation, give solutions to the nearest thousandth. Okay, so this one's no different. As a matter of fact, here though, we take the natural log anyhow. Probably why they put this up here, they're expecting us, well, I don't know what you're doing. They were expecting us probably to be taking log with base 10. But, and if I have a base of e, in most problems, it doesn't matter if you use log with base 10 or natural log. Unless your base is either a 10 or an e, and technically still it doesn't matter, but it'll save you a ton of work if you use the corresponding logarithm to go with the corresponding base. So let's see why. So if I notice, oh, my base is e, even if I like using log with base 10, I'm going to use natural log here. Let's see why. So I'm going to take the natural log of both sides. Okay, because this means my base is e and this is e, right? I can just bring that x squared down. Look how much shorter it made my problem. Okay, now square root both sides. So x is, don't forget, if I put the square root in the problem, I got to do plus or minus natural log of 200. Okay, it says again to the nearest thousandth. So first I'm just going to do the natural log, the square root of the natural log of 200. And I get 2.302. Okay. And then also negative 2.302. Okay. Now remember what I'm checking when I said checking, we're checking the argument. So far we haven't had anything to check inside the argument, right? Inside the logarithm. Okay, notice over here I got a bunch of bases the same, all right? This looks like a complicated problem, but I have to recognize, I've got to recognize my differences in the kinds of equations I have. Okay, if my bases are the same, hey, I can combine that. I always try to make everything as simple as possible. I can make this, if I have bases the same, exponential numbers where the base is the same, I can combine them into one base by adding the exponents. So I'm going to add 2x plus 1 plus negative 4x. So what am I going to get there? Negative 2x plus 1, right? Just add the exponents, equals 3e. Hey, I've got an e over here. Okay, now remember this is e to the 1. If I have exponential numbers with the same base being divided, I subtract the exponents. So negative 2x plus 1 minus 1 . Okay, so simplify first. Try to simplify, and I've got to have just one term over here that I'm taking the log of anyhow. So natural log of e to the negative 2x is the natural log of 3. And notice, because this has a base of e and this is a base of e, right? It just leaves the exponent. Negative 2x equals natural log of 3 divide by -2. So x equals natural log of 3 divided by -2. Negative 0.549. Okay. If I'd have tried to use log of base 10 here, I'd have log of base 10 of 200, I'd have this log of base 10 of e, and I'd have big, long, complicated problems like we had earlier. Log of base 10 of 200 minus log of base 10 of e divided by, right? So match your base to your logarithmic base. Okay. Notice the difference in this one and that last one we worked. Right, that very last one we worked, I had a bunch of terms with e's in them, and I said, oh, look, they all have the same term, but they were being multiplied. I do not have properties of exponents or logarithms, because they are exponents, that allow me to combine terms with the same base if they have different exponents, right? That's not a property. So what I want to recognize about this is, hey, it's got 3 terms. That certainly, anytime I see something with 3 terms, I'm thinking quadratic. Okay, let's go back just a minute. Look at the way this looks like. Look at what this looks like, this equation, versus this equation. It doesn't have 3 terms. It doesn't have 3 terms, right? This is all one term. Terms are separated completely by plus and minus signs. This is not. I could combine this into one term. It is one term. Okay, so that's the difference. All right, so once I recognize that, just to double check it's quadratic in form, remember our second step, if I take this exponent here and multiply it by 2, is it sitting right there? Yes, it is. This is quadratic in form. So remember our step. We replace this whole variable term, not the numeral, just the variable part, with u. That automatically means that u squared is e to the x squared, or e to the 2x, right? E to the x squared, you multiply e to the 2x. Okay. So we just rewrite our equation using u's instead of e to the 2x. So this whole thing, e to the 2x, is u squared minus 4u plus 3. Now it looks kind of regular, so I can factor it. Okay, so I need 2 numbers that multiply to give 3, add to give -4, u minus 3, u minus 1. So u is 3 or u is 1. But don't forget, u is actually e to the x. So I've got to substitute back in. E to the x is 3 or e to the x is 1. Okay, so now what am I going to do? Right, take the log of both sides, specifically the natural log. So the natural log of e to the x is the natural log of 3. Natural log of e to the x is the natural log of 1. But this is just saying x is the natural log of 3. Okay. Notice this time it says give exact values, and that's what your test is going to be. So that's your answer. You don't have to plug it in your calculator. Okay. This again, because they had the same base, is x equals natural log of 1. So your two answers were natural log of 3 and natural log of 1. Okay, so you've got one like that on your homework, I know of, at least one, so careful with that. Okay, now notice we've already got the logarithm in our equation. So how do I get rid of a logarithm? Okay, earlier we had exponents. The question was, how do I get rid of that exponent? Take the log. It'll let you bring it down. Oh, I have a log. How do I get rid of the log to solve for x? Change it to exponential form. Change it to exponential form. Now, before I do that, I cannot have a numeral out front here. So I got two choices. I could either bring this up and make it natural log of x to the 7th, or when I notice what would make this so much easier, instead of having an x to the 7th, I could just divide. Anytime I could just divide, but particularly here since it doesn't leave a nasty fraction, but I don't want an x to the 7th anyhow. Okay, so natural log of x equals 4. Change it to its exponential form, right? So this is the base. This is the exponent. Oh, you've already solved it for x. It says give exact values, so we're going to leave it like that. If it said round to the nearest 1,000th, you'd plug that in your calculator, right? Now, here's where, once we have variables inside our logarithms, that's where we got to start thinking about checking our answer. But e to the 4th is a positive number, so I don't have to worry about that ever being negative, because that 4th power, and e is a positive number, right? 2.718, Okay. Okay. This one's already set up where I just have the log of something, right? One logarithm, so change it to its exponential form. Here's your base. Here's your exponent. Okay, now we've got an equation we can solve, a cubic equation. So this is 8. So we have x cubed minus 19 equals 8. Let's subtract 8 from both sides. Okay, so we wind up with x cubed minus 27 equals 0. This is the difference of cubes, so I got to know how to factor. Cube root of each term, square this one, multiply them together, square the last one, same, opposite, always positive, got to be able to factor. So we've got x minus 3 equals 0, so x equals 3. Now don't forget, I got to check that answer before I box it. So 3 cubed is 27, minus 19, that's positive, so that's fine. This we got to solve by the quadratic formula or completing the square. Since it'd make a fraction, let's do quadratic formula. So negative b plus or minus the square root of b squared minus 4. A is 1, so c. 4ac all over 2a. So we have negative 3 plus or minus the square root of, that's going to be 9 minus 36, right? 9 minus 36 is some negative number. These are complex solutions, right? Complex solutions. Okay. Because it's got to be positive. Okay. Same thing. I see logarithms in my problem. I'm thinking, oh, I'm going to change it to exponential form. I can't change it to exponential form, though, until I have just one log. So I have a way to combine logs that are being added and subtracted. That means this is the log of x plus 6 over x plus 2 and equals log of x. Okay, using those properties. Now, I could subtract this over here and continue make this equal 0 and then have some problem, but notice this is log with base 10, that's log with base 10. Hey, if they're the same thing, now it's not because I'm dividing by log with base 10, you can't do that. You can't do that. But what this is saying is basically if the log is the same, the argument is the same. It's that same idea. If the base is the same, the exponent is the same. If the exponent is the same, the base is the same. If the log is the same, the argument has to be the same. Right? So x plus 6 over x plus 2 equals x. And there's an equation without any logarithms in it. So we can solve it. Let's multiply both sides by x plus 2. So that'll cancel, and we have x plus 6 equals x squared plus 2x. Oh, it's a quadratic. So let's set it equal to 0 and try to factor it. Minus x, so that's gone. Minus 6, so that's gone. So x squared plus x minus 6 equals 0. So two numbers that multiply to give negative 6 times 1, negative 6, and add to give positive 1. So plus 3 and minus 2. So we know x equals negative 3 or x equals 2. Now, before I box them, I have to check my answer. Oh, negative, I can see right here, that's not going to work. 2 is okay here, and 2 plus 6 and 2 plus 2, those are all positives. So my only answer is x equals 2. Now, again, just a note. If we didn't think about that property, one thing I could have done is said, oh, I know I'm trying to get all of my, I've got to get, just one logarithm. If I'm thinking in those terms, I could have subtracted that log of x from both sides and then combine these. Because it's a minus, it will go in the denominator. It will go in the denominator, right? And now if I changed it to exponential form, I have to know this is 10. So 10 to the 0 would equal x plus 6 over x times x plus 2. Anything to the 0 power is 1. Let's go ahead and get rid of those parentheses. And then here's my equation without any logs. If I solved it, I'd first step get rid of those parentheses. Get rid of that denominator. Don't forget your parentheses. And notice I'd wind up back with the exact same equation. There it is right there. There's the x squared plus 2x equals x plus 6. And then continue to solve it. So it just saves me some steps to think about some of these things. But if I happen to miss it, I can still trudge along and just follow my basic ideas, right? Okay, they got a caution for us. The domain is got to be positive, right? So it's always necessary to check. We already know that. It's always necessary to check, okay? Okay, same thing here. Hey, this already is. It's just log of some stuff equals 3, I can just immediately change that to its exponential form. So 2 cubed equals, I'm going to go ahead and multiply this out, right? 3x squared minus 12x minus 7x plus 28. Okay, this is 8, right? So I've got a quadratic equation, so I'm going to set it equal to 0. So let's subtract 8 from both sides, 8 minus 8. So I wind up with 3x squared minus 19x plus 20 equals 0. Let's see if we can factor it. Okay, I'm going to need a couple of numbers that multiply and give 60 and add to give negative 19. What about 15 and 4, right? Negative 15 and negative 4, that is 60, and it is negative 19. So, need to factor. I'm going to say it constantly. Got to be able to factor. Let's just rewrite our negative 19x using those two numbers so that now I can factor by grouping. Okay, so I can factor out a 3x, which leaves x minus 5. And I can factor out a negative 4, which also leaves x minus 5. So I have x minus 5 times 3x minus 4 equals 0, means one of them's got to be 0. So either x is 5 or x is 4/3. Now, before we box them, we have to check it. So, okay, so if x is 5, let's check it in the argument. Let's go over here for a check. If x is 5, we would have 15 minus 7, 8 times 1. That's okay, that's positive. If x is 4/3, 3 times 4/3 minus 7 is what that would be, right? And then 4/3 minus 4, right? If x is 4/3. So here I would have 4 minus 7. And here, I don't really care what the numbers are, but I know this is negative. And this is also negative because 1 1/3 minus 4, so that's a negative. So both of them work. They both might work. One might work and not the other. Or neither of them might work, and then I'd have a no solution scenario. But these were both positive arguments. Made the whole argument positive, so I'm okay with that. Okay, this is two separate logarithms. Can't have that, right? Got to combine it because it's being added. I've got to multiply those arguments to combine it into one logarithm. Okay, now that I have one logarithm, I can change it to its exponential form. Base is 10 if it's not written, so 10 to the 1, and I'm going to go ahead and multiply that out again. So 3x squared minus 3x plus 2x. Some of you might do that in one step. That's fine. I'm just for clarity trying to show everything. Okay, so I'm going to set it equal to 0, which means I'm going to subtract 10 from both sides. 3x squared minus x minus 12 equals 0. This time I need two numbers that multiply to give negative 36 and add to give negative 1. Okay, not going to happen. So first thing I'm going to do is check my math. Okay, so 3x squared minus plus, and then we had a minus 2, 10 to the 1, minus 10. Okay, so let's do the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we have 1 plus or minus the square root of 1 plus 144, right? Is that a 3? Yeah. 12 times 12, 144 over 6. Okay. So x is 1 plus or minus the square root of 145 all over 6. Okay. So the square root of 145 is larger than 1. I know that. So this is going to be a negative value. And if I plug it right here, I automatically know that if the whole thing is negative minus a negative, this is going to be negative. Okay, but what if that's positive? So let's see if we can plug in and figure out. I still don't know why they'd give you anything that you can't really check when you need. Well, they're thinking you have a calculator. Okay, we wouldn't give you anything that you couldn't check without a calculator on your test. But I'm going to double check again because they shouldn't give you one like this. 3x squared minus 3x plus 2x minus 2. So that is a minus there. 10 to the 1. 10. So negative 12. Negative 36 and negative 1. Okay. So if you're on your homework, just plug those in, right, and see which makes it. Let me real quickly get myself also 1 plus square root of 140 square root all right. So with the plus, we've got basically 2.17, and with the minus, we've got negative 1.8. We knew it was negative something, right? Negative 1.84. So let's try to plug these in. Okay. So this one's going to be positive, right? Because 3 times 2 is 6, that's positive. 2 minus 1 positive. So this one's okay, the plus part. I'm thinking we're going to have a problem with this, and it's what they wanted us to see, but I don't know. Let's see. Let's say plug that in. Negative 1.8 plus 2. So that's negative and that's negative. Oh, so they're both positive, so both answers work. So if you have this on your homework, do what I just did. Plug it in your calculator and check it. Okay, it will not be on the test. One like this that you can't really check thoroughly without a calculator and without 5 minutes of work. Okay. All right, let's look at another one. Okay, bunch of natural logs. They're more than one equation, though. But I can combine it. I mean, more than one term. I can combine it into one term, though. Natural log, because it's a minus, right? Hey, look right here. I might notice this too. If I didn't notice, it just makes it a little more complicated. But if I notice this is a natural log with a base e, it just helps me. This really is just natural log of x, right? So since I'm going to combine, let's go ahead and write that for you. So that's natural log of x minus natural log of x minus 3 equals natural log of 2. Okay, because it's a minus, I can combine it into one natural log if I use division. And then once again, if I notice, oh, hey, it's a natural log on both sides, then if the logarithms are the same, the arguments have to be the same if I'm saying they're equal, right? So x over x minus 3 has to equal 2. And then there's an equation we can solve. Let's multiply both sides by x minus 3 to get rid of that fraction. So x equals 2x minus 6. That's just a linear equation. Let's subtract 2x from both sides. Negative x equals negative 6. So x equals 6. Let's plug in. This is okay. 6. 6 minus 3 is positive. Okay. That does it not only for this section, but that is the end of chapter 4. All we have left, guys, is chapter 5, and most people find chapter 5 to be the easiest in the course. So I hope that's true for you. Let me know if you have any questions, and I'll see you next time.